looking a little bit different from the start. Hopefully we'll make our lives actually simpler anyway. If I want to get my, if I look at my variables, the x's are all already ones. I would, just to keep everything lined up, I would insert a 0y. You don't have to. It kind of depends on how confident you are. If you like things lined up, this is the way to go. Yeah.
Can't you just use that as the second one? Like you just get the
yeah.
Two of them?
Yep. You can. I'm going to just keep it consistent, though, just to keep people very, yeah. So on the first two, I'm going to subtract. So I got 0 x's, negative y's. 1z minus 2z is negative z. 8 minus 17, negative 9. I hate that equation, but I'm going to fix it in a minute, I think. I would just make that y plus z equals positive 9. But I'll keep it like this for those of you who don't necessarily want to go down that route. Second two equations also subtract. 1y minus 2y is negative y. 2z minus z is plus a z. 17 minus 16 is 1. And now those y's are already opposite of it, or already the same. Same sign means subtract again. So I get negative y minus negative y gone. Negative z minus z is negative 2z. Negative 9 minus 1, negative 10. Z equals 5. Go back. Negative y plus 5 equals 1. Negative y equals negative 4. Y equals 4. Go back. X plus 2 times y is going to be 8. 2 times 4. Plus your z of 5. Subtract your 13 from both sides. X equals 3. I did notice that some people on your homework quiz did get whole numbers. And just to be clear, and I don't know, maybe you guys knew something wasn't right. Like people who got it wrong but had whole numbers. Maybe you knew something wasn't right, but you just couldn't find it. I don't know.
Yeah.
But if you got whole numbers and you thought it was right, what you can and should do just to be sure is just check your solutions in all three equations. So 3 plus 5 should equal 8. That works. Your x of 3 plus your y of 4 is 7. Plus 2 times your z of 5. 7 plus 10 is 17. So that works. And 3 plus 8 is 11. Plus 5 is 16. Whatever you get probably coincidentally will work in at least one of the equations, just by kind of the way that this rolls out. It should work in at least one, even if you did something wrong. But you'll know it's 100% right if it works in all three. Okay? Ryan.
So when there's like a missing variable, you just add in a variable with a 0 in front of it, and it acts like a
correct.
Just a y?
Yep.
Okay.
0y. Yeah. Yeah. That's my recommendation, just to keep it as similar to the rest of them as we possibly can. The only real new thing you're doing, and I actually have started to do this with my Algebra 2s. I don't think Mrs. Zigai or Mr. and Mrs. Hill do this, but maybe I'm wrong. Because there's really no application. Like, why are we doing a system in 3 variables? Like, why would we do that? And really the main spot would be to write the equation of a quadratic if you know 3 points, right? Lines, to write the equations of lines, you only need 2 points. If you want to write the equation of a quadratic, you need 3 points. And those points are x's and y pairs, okay? So this application you can expect to see on a test or a quiz tomorrow. But it's pretty easy. So basically what you have, again, are x and y coordinates. So for each of these 3 points, I'm going to plug in xy to the structure of a generic quadratic. So my y for the first point will be 4 equals a times 1 squared plus b times 1 plus c. So that will clean up to being 4 equals a plus b plus c. Then I'm going to do it with my second point. So that's a y of 1 equals a times 2 squared plus b times 2 plus c, which will clean up to 1 equals 4a plus 2b plus c. And your last one, 3, 4. Cleans up to 4 equals 9a plus 3b plus c. And then you just solve the system. So one of those variables, they're all already the same. C. So on my, I don't need any multipliers. And actually, C will always be the same, right? Because the x and the y coordinate don't affect your C. So if I subtract, I get 3 equals 1a minus 4a is negative 3a. 1b minus 2b is negative b. On my second two equations, they're both the same sign, so subtract there as well. I get negative 3 equals negative 5a minus b. And then on my third and final round of elimination, I still don't need a multiplier, which is nice. Sometimes I will here, depending on the problem. But again, those b's are already the same. Same sign means subtract. So subtract, subtract, subtract. 3 minus negative 3 is 6. Negative 3 minus negative 5 is negative 3 plus 5, which is 2. And negative b minus negative b is gone. So a is 3. Go back up to the previous layer and plug in that a of 3. Solve for b, so that's a negative 15. I'm going to add 15 over. I get 12 equals negative b. Divided by negative 1. b equals negative 12. And then go back to your layer before that and just solve for C. 9 times 3 plus 3 times negative 12 plus C. I'm going to subtract 27 over, add 36. $40 minus 27 is 13. So checking this one's a little bit different, can be a little bit different because it might check in the system that you wrote, but what if you made a mistake writing the system? So a way that you could check this one, give me 1 minute, is we think we know the a, b, and c. Oh, we actually have to write the quadratic function. So we would just write y equals 3x squared because our a is 3, minus 12x because our b is negative 12, and then plus 13. And you can just type that function into your y equals and look at a table just to make sure those 3 points are on it. So 3x squared minus 12x plus 13. Look at your table. See if 1, 4 is on there. It is. See if 2, 1 is on there. It is. And 3, 4. It is. Okay? Truthfully, I'll tell you how I write these equations. I'll just make up, if I want to write a problem like this, I'll just make up 2x squared minus 5x minus 8. So my a would need to be 2, my b would be negative 5, my c would be negative 8. That's what I want the solution to be, and then I'll just look at the table and I'll grab 3 points and tell you those 3 points. Does that make sense? That's how I'll write it to make sure it all works out. What I won't ever give you probably is the y-intercept. Because if I give you the y-intercept, then I'm already giving you the c value. You guys know that, right? So I probably won't give you the 0.0 negative 8, but anyway. Brock, did you have a question?
I don't know why plugged it into the middle one.
So
Into
A,
that one.
this one?
Yeah.
1 equals 4 times A plus 2
I
times,
mean, it's 1 minus 12, so what do we get?
2 times B. Did you have B yet?
No.
You
No.
Put it in the second.
So you can't put it in this one because
Yeah.
you're still missing 2 variables. So once you find an A of 3, you first have to go back to one of these, because then you'll only be missing 1 variable. Then when you have 2 answers, you can go back and find the third. Any other questions?